Welcome. Today we're going to be talking about metric conversions. We're going to talk about how to convert from grams to milligrams, or grams to kilograms, or liters to milliliters, or liters to centiliters. So I'm going to show you two different approaches today of how you can do these problems. Whatever works best for you is great. Please don't forget to take the mini quiz whenever you're finished watching the notes. This metric conversion chart we put in our notes last week. We're going to refer back to it a lot while we're doing these metric conversions. I highly suggest that you memorize this chart. And again, these multipliers just mean how many grams there are per kilogram. So there will be 1,000 grams in 1 kilogram, or 1,000 liters per kiloliter. Same thing down here. We'll use deci for example. There'll be a tenth of a gram per 1 decigram, or a tenth of a liter per 1 deciliter. The first method that we're going to learn about today for conversions between metric units is the T-chart. This works really well for all different types of conversions, even outside of just converting between metrics. The T-chart is also best in more advanced sciences, so this is what we're really going to try to get familiar with, and we'll be using it more and more as we continue on in the year. Our first problem is 104 meters equals how many millimeters? To start our T-chart, the first thing we have to do is set up a T-chart, and then in our upper left-hand corner, we put what we want to convert, which in this case is 104 meters. Next, we need to figure out how many meters are in 1 millimeter. So looking back at our metric conversion chart from last week, there are 1/100th of a meter per 1 millimeter. So going back to our T-chart, there are 1/100th of a meter per 1 millimeter. The reason we put this inverted like this is so that our meters here will cross out and we'll be left with our units of meters. Again, there's 1/100th of a meter per millimeter. So we plug it into our chart, and we want our meters to be able to cross out so that we're left with only millimeters. The next thing that we need to do here is we're going to multiply across the top here and divide by the bottom. Our meters here are crossing out. We're just talking about that. So we take 104 times 1, which is 104, and then plug it into your calculator. You divide by 0.001. Again, we multiply across the top and divide by everything on the bottom. So 104 times 1, which will be 104, and then we divide our 104 by 0.001. If you put that into your calculator, you should get 104,000 millimeters. So 104 meters equals 104,000 millimeters. We're going to do another example of this here in just a second. Next, I'm going to show you the jump method. Here's our problem for the jump method. We have 6.3 centimeters equals how many millimeters? Since the metric system is based on the unit 10, just like the decimal system, we have tenths, hundredths, thousandths, tens, hundreds, thousandths. When we convert, we can just move the decimal point. I think that this is probably the easier way to go in the beginning, but again, the T-chart becomes more important over time. You guys may have heard the mnemonic device, King Henry died Sunday drinking chocolate milk. That's just a way for people to remember the order of our chart. Where's our chart? Of this chart, King Henry died Sunday drinking chocolate milk. So when they think of that, they can put it into these boxes. To go from centimeters to millimeters, we're going to start at our centimeters. We make one jump to the right to our millimeters. We're going to do the same thing up here with our decimal point. We move our decimal point one jump to the right. So we have 6.3 centimeters is going to equal 63 millimeters. I switched that up on this next slide. Sorry about that. So we get an answer of 63. We're going to do another one of these here in just a second as well. Our next problem, we want to compare these two units using greater than, less than, or equal to. We have 63 centimeters and 6 meters. This one in your mind you might be able to visualize and know that 6 meters is much larger, but there'll be other problems where the visualization won't be as easy. So we're going to learn how to do it here with this simple problem. The first thing we need to do is convert into similar units so that we can compare them. First, we're going to do this using the jump method since we just talked about it, and I think that it's the easier one. To get from centimeters to meters, which is our standard unit, we're not going this way. If we wanted to get to this mm, we'd have to have an mm up here because meters is our standard or base unit. This works with any standard or base unit. So from centimeters to meters, we make one jump, two jumps to the left. Next, we're going to do the same thing with our decimal point. One jump, two jumps to the left. That's going to give us 0.63 meters, which is significantly less than 6 meters. Or we're going to do the same problem now using the T-chart to figure out the conversion. So same problem here, compare 63 centimeters to 6 meters using greater than, less than, or equal to. So to set up our T-chart, we put what we want to convert in the upper left-hand corner, which in this case is 63 centimeters. We know that there is 0.01 meters per centimeter, 1/10 of a meter per centimeter. So in 1 centimeter, we have 1/10 of a meter. Our units are going to cross out here. Centimeters and centimeters cross out, so we're left with our target unit. And then we multiply across the top and divide by the bottom. So 63 times 0.01 divided by 1. When we divide that out, we're going to get 0.63 on top here, 0.63 divided by 1, which is going to be 0.63. This is going to go up here. 0.63 meters is less than 6 meters, and we get the same answer. That completes our mini lecture for today. You guys have a quiz to do on Google Classroom. Your scores for your quiz will be automatically sent to you through the email that you type in. So whatever email you use, whatever email you check, will be the email that your score gets sent to. You can check your student email by going to the Gmail tab under where you would access your Google Docs, and your score should be in there. It will be expected that you have a basic understanding of how to complete these problems when you come back to class. If you need to rewatch the video, please feel free. I strongly urge you guys to actually work out these problems versus just typing it into the computer in a Google search or whatever, so that you are prepared for class and for your scientific future. Thanks. Have a great night.